Welcome to the DIY Honda Garage channel. The DTC P16C5 indicates a malfunction within the engine mount actuator control system. This specific error points to a condition where the power circuit is stuck in the on position, potentially leading to issues with the engine mount function. The engine mount control unit is a critical component that plays a vital role in controlling engine vibrations and ensuring a smooth driving experience. Located near the engine mount control unit operates alongside the active control engine mount, ACM, and uses associated relays to manage operations. When the power circuit remains on, it can lead to incorrect functioning, causing potential damage or performance issues. The diagnostic trouble code provides a starting point for determining further diagnostic steps to identify the root cause of the issue. The DTC P16C5 relates to the engine actuator control for the active control engine mount system. This system is designed to reduce engine vibration by adjusting the position of the engine mount in real time. The engine mount control unit, positioned close to the engine, helps in reducing vibrations and improving ride comfort. When the power circuit is reported as stuck on, it indicates a malfunction that needs to be addressed. This is crucial because maintaining optimal engine performance and driver comfort is a priority in vehicle design, especially for a family-oriented vehicle like the Honda Odyssey. Identifying this issue early can help prevent further complications or damage to other vehicle systems. There are multiple potential causes for the DTC P16C5, mainly revolving around electrical issues. Poor electrical connections could lead to intermittent power issues within the system, making diagnosis challenging. Loose terminals can prevent proper connectivity, resulting in the system showing faulty readings. Additionally, a malfunction or failure within the engine mount control unit itself could lead to the signal staying locked in the on position. Each of these causes emphasizes the importance of ensuring that all electrical connections are secure and functioning as intended. Analyzing these aspects thoroughly is essential to effectively resolve the issue and restore normal functionality. The symptoms associated with DTC P16C5 often manifest in various ways. Drivers may experience increased engine vibrations, which can lead to an uncomfortable ride, especially in a vehicle designed for family travel like the Odyssey. Alongside vibrations, strange engine noise may also occur, indicating that the engine mount is not performing adequately. Additionally, the vehicle's dashboard may illuminate warning lights related to engine performance, signaling that the system requires immediate attention. Recognizing these symptoms is critical for timely repairs, as ignoring them may lead to further damage to the engine or associated components. The first troubleshooting step involves setting the ignition to the on diddle position. This is essential for activating the vehicle's electrical systems without starting the engine. Next, utilizing a Honda Diagnostic System, HDS, check the active control module, ACM, unit supply voltage alongside the ACM control relay. The essence of this step is to verify whether the ACM unit is receiving adequate power, while the control relay indicates an off status. If the ACM unit shows battery voltage, this confirms that it is receiving power. If not, an intermittent failure could be at play. Intermittent failures often highlight issues like poor connections or loose terminals, suggesting further checks are required. In this second step, the ignition switch should be turned to the lock 0 position to safely perform further testing without electrical interference. Following this, remove the active control engine mount, ACM, control relay for an isolated assessment of the system. The next major action involves disconnecting the engine mount control unit's 16P connector, facilitating direct access to the electrical terminals for continuity testing. This step is critical in ensuring that the relay and connector do not contribute to the reported issues. If the relay and wiring appear functional, it allows the technician to confirm the integrity of these components before proceeding to further electrical checks. Now, continuity between terminal number 16 of the engine mount control unit's 16P connector and body ground should be checked rigorously. This test is essential for determining if the circuit is properly grounded. A positive continuity reading indicates the existence of a short to ground in the wire between terminal number 16 and the active control engine mount, ACM, control relay terminal number 4 socket. Repairing this short circuit is crucial for restoring the correct functioning of the system. On the other hand, if no continuity is found, it suggests that there might be other underlying issues necessitating further investigation into the wiring and component integrity without jumping to conclusions. This fourth step requires the ignition switch to be set to the on I2 position again. This ensures that the system is powered on for voltage measurement. The actual measurement process involves assessing the voltage present at terminal number 6 of the engine mount control unit's 16P connector in relation to body ground. It's vital that this voltage is an established level for the unit to perform correctly. By checking this terminal, technicians can ascertain if the engine mount control unit is receiving appropriate power to function properly. If the measurement indicates a lack of voltage, this could point toward a failure in the wiring or in the control unit itself that warrants immediate troubleshooting. Final repair verification is a crucial phase that ensures all diagnostic and repair actions have been successfully executed. This step starts with confirming that all necessary repairs have been completed to fix the underlying issues indicated by the DTC P16C5. Following this, the technician should rerun a diagnostic check to determine whether any diagnostic trouble codes still persist. After verifying that all codes have cleared, a road test is essential to confirm that the vehicle operates smoothly without vibrations or abnormal noises. This testing phase ensures that all systems function harmoniously, re-establishing reliability and comfort in the Honda Odyssey. Only after completing these steps can the service be deemed thorough and effective. Preventive maintenance plays a pivotal role in extending the lifespan of the components affected by DTC P16C5. Regular inspections of the electrical system, particularly focusing on connections and wiring in the engine mount control assembly, aid in identifying potential problems before they escalate. Additionally, routine assessments of the engine mount functionality can help ensure that any wear and tear are dealt with promptly, preventing unexpected breakdowns. It's also vital to address any early warning signs, such as unusual vibrations or noise. Nurses a more comprehensive review of the system. By implementing these measures, vehicle owners can maintain optimal performance and avoid costly repairs down the line. In summary, the DTC P16C5 signifies an issue within the engine mount actuator control power circuit, emphasizing the need for careful troubleshooting. Key actions involve checking electrical connections and inspecting continuity to identify any shorts that might be causing the malfunction. Each troubleshooting step lays the groundwork for isolating potential causes, ensuring a more efficient and effective repair response. Preventive maintenance is vital for prolonging the life of components and systems, enhancing the overall reliability of the Honda Odyssey. Addressing these errors promptly can greatly improve driving comfort and performance. Following through with all recommended steps ensures technicians can effectively resolve issues and maintain vehicle integrity. Please like and subscribe to the channel. See you next time.